Okay, so what we've done so far is look at general concepts in inter-process communication. Then we looked at general concepts in remote procedure call. And we were looking at RMI. And RMI can be used in two contexts, just the idea of remote method invocation in an object-oriented language, or Java RMI. And I'm going to use these both interchangeably for now. So the problem, so the goal here is to figure out how Java's RMI allows us to create these three concepts. Okay, how does it allow us to create remote objects whose methods can be invoked remotely, and that in turn means how it requires us to create remote classes whose objects can be remote, and we need to store these objects in variables. So that brings in remote variables, and we said that we want distribution unawareness in our calls. That means a remote variable should be able to store either a proxy to the remote object or the remote object directly. Okay, so we're going to look at the concepts that allow in Java RMI that allow these three kinds of entities to be supported. Okay. And to make this all concrete, we looked at an example last time. This is pretty much the simplest example I could come up with. And first I described the interface of that example, where we have a counter interface which allows increment and get value. We then created a class that implements this interface. And now our goal is to go and allow this counter functionality to be invoked remotely, okay, in this example. And let's assume for now that our remote classes are distribution unaware. That means we can use any class at all as a remote class. Okay, so let's assume for that. And let's assume for now that. And this means that we should be able to create a variable such as counter, on which we can invoke all the methods in the server class a counter. Okay, remote class a counter. And in that counter variable, we should be able to store both proxies to the counter object or the counter object directly. Okay, so these are our goals in the context of this example. And we saw that errors can occur. Errors can always occur, but there are certain errors that occur only in a distributed context. And those errors in Java are captured as remote exceptions by the type remote exception. And we saw that distribution errors are things that a programmer can't avoid. So we will make remote exception that RMI supports a checked exception. Okay, any exception that has to do with a distribution error, we'll make a checked exception. And remote exception catches a lot of the distribution errors. It encompasses many of the distribution errors. Okay, so we need this try-catch block. And this try-catch block is going to be important in our discussion. So this is our code. And somewhere we need to have declared the variable counter. We need to give in a type language like Java, we need to give it a type. And I'm just putting the word T here because I don't quite know how to type it right now. Okay. And the question I'm going to answer now is, how do we type remote variables? Okay, and these are variables that can store both proxies to remote objects or the remote objects themselves. Okay, so that's the question we ended up with last time, and we're going to resume that question in this class. Okay, and we came up with many answers, and any answer that you come up with should satisfy the following property. Since two kinds of objects can be stored in this variable, one is an instance of a counter, which is our remote class, and the other is an instance of a proxy. We don't know quite what the name of that class is, but we know it's a proxy. So I'm just calling it a counter proxy. Who knows what the name really is? That proxy is created by the system, and it may or may not tell us what the name is. So for now, we'll just give it the name a counter proxy. And given that there are these two classes, we need both of these classes to be special cases of this type T. Okay, so that's a constraint on any answer we provide for T. So let us go and see the different ways in which we can meet this constraint and argue whether these solutions work or not. One is to make it object. Okay, every class is a object. Okay, so we satisfy the property, but then we get into the obvious problem that we can't invoke counter-specific methods, okay, without casting it. So we don't want to cast. So so that won't work. Okay, that's why we don't type things as object. We type things with a specific type. So every class is so class T is a T. Any class C is a C. Okay, so we can say that, look, maybe counter proxy and counter are the same class. Okay, that would meet this requirement. Okay. But then you can't have different behavior for objects and proxies. Okay, when you invoke the increment method on a remote object directly, we want the increment to occur. When you execute it on a proxy, we want the method call to be forwarded to a remote server. So we want different behaviors for increment based on whether we are using a proxy or a direct object. Okay, if they're the exact same class, there's no way to distinguish among these two objects, so that won't work. Okay, so these are sort of the simple solutions that we can dismiss. And then I suggested this solution, that we make the proxy class extend the remote class. Okay, and we saw that, at least two of you voiced the problem with the solution. One was that logically it doesn't make sense. Okay, because a proxy and these two classes do two different things. Okay, that's what David said. And then UG said that, look, the proxy class just needs those methods that forward. It doesn't need the other methods. Okay, so by both arguments, it should not be that class. Okay, but let's say you do that. You say, okay, the system takes the class and creates a subclass of it that has proxy methods, and overrides all the methods. Which seems all wrong, but it works. Okay, and maybe from a puristic point of view, pure point of view. From the point of view of a purist, okay, this won't work, but maybe we can make it work. Okay, later. So another problem that occurs from a practical point of view, forget a purist point of view, is that all callers of remote methods have access to the implementation of the remote methods. Okay, so we may not want that for security reasons. There might be a remote object that has proprietary code and it wants other clients to go and use that code. So we don't want that to happen. Okay, and even if we don't care about that, every time we change the class in the call process, we have to go and change the class in the calling processes also. Okay, you guys have seen with the grader that if every time I change my jar, you guys all have to download a new version. So that's a pain. Okay, so we don't want this either. So what's the solution? And the solution is staring us in the face here. I was very good. I used the 401 rules that I've taught students who took the class from me by creating an interface for the class. Okay, and what we want is the two classes to have the same headers, so that our type checking rules are happy, and we want and so we can have the counter proxy and the counter both implement the same interface, and we already have an interface counter. We don't have to create the interface, so we'll just tell Java to create an instance of the counter interface that goes and forwards the methods to the remote object. Okay, so this is more or less it. Okay, interfaces is the key here. Okay, except that we have still a little problem to worry about. Okay? And that problem I mentioned was that this also won't work, and it has to do with the try-catch block that we see here. So I asked you guys to think about why the try-catch block that you see here is inconsistent with what I've said. And then Andrew was coming up with a solution, and we had to interrupt. So we'll see whether Andrew can rethink his solution, or you other guys can think of the problem here, and then we can think of the solution too. Okay. So the problem which Andrew alluded to is the fact that, and I'm going to say it in a different way, our counter of interface is remote exception unaware. Okay, it doesn't anyway say that a remote exception can be thrown by the headers. Okay, and this try-catch block is not valid. Java will scream at you if you have this try-catch block. It will say, sorry, you're trying to catch a checked exception, and the checked exception, I guarantee you, cannot be thrown by this code. Okay, so if you ever say catch file not found exception in a block that just increments an integer, Java will scream at you and say, sorry, there is no file accessed here, so why are you trying to catch an exception that can't be thrown? Okay, and it's going to say that it doesn't throw this exception because, as Andrew pointed out, the headers of in a counter do not say that that method can throw a checked exception. Okay, so our interface solution more or less works, except for this problem with caught exceptions. Okay, so programmer is not forced to catch errors to a potential remote call if we don't go and put in the headers the fact that the methods can throw remote exceptions. Okay, so how do we fix this problem? Well, we'll go and create another interface called distributed counter. Okay, not counter. And distributed counter is like counter, except that every header there goes and says, every method header there says that the called method can throw a remote exception. Okay, and any remote interface, any interface of a remote object that we create, we need it to have the property that every method in that interface says it throws a remote exception. Okay, so we've done that. We've gone and said both methods throw a remote exception, even though Java will let us go and declare a method that doesn't say it throws a remote exception. But since we want Java to do some checking, we will also go and say that our counter interface extends remote. Remote is an interface provided by Java as a predefined interface with no headers. Okay, so all we're doing is using it as a label. And we're telling Java, please, I'm going to be using this for a remote object, and please ensure that every method that is in this interface, its header says throws remote exception. If it doesn't, scream at me. Scream at the programmer. Okay? And whenever a language screams at the programmer, it can do it at compile time or it can do it at runtime. Java is actually a compile time checking language, but it does throw certain exceptions at runtime. And so this is what's happening here, that we are saying throws remote exception, and we have made our counter extend remote. And like I said, Java, if an interface I extends remote, then Java checks that methods declared in I throw remote exception. But the check will be done at proxy creation time and not at compile time. Okay, so if you never create a proxy for that interface, if you only use that interface locally, Java says that's okay. Okay, you haven't done anything wrong. So I will go and scream only if you try to create a proxy. Okay, and so now I'm going to have a separate class called a distributed counter that says that it implements this remote interface. Okay, and that will allow us to have the property that we wanted, where the actual counter class and the proxy class are both subtypes of a common class. Okay, so by making a distributed counter by making the class a distributed counter, implement the interface distributed counter, I have made sure that my class is a distributed counter interface, and that is the interface we use to type the remote variable. Okay, so remember our T has become distributed counter, and this way we make sure that our remote class is a T, and we don't know how the proxy class is exactly generated, but we can make sure that the proxy class is a T also is a distributed counter also. Okay, so we've got this relationship, and we have this picture that I was talking about, that my remote class, a distributed counter, is a distributed counter, the interface used to type the counter variable, and Java will make sure that a counter proxy also implements a distributed counter. Okay, so we have satisfied the property we were looking for. Okay, so this works. This is exactly what you will do, except that we've lost a property that we wanted. My remote class is no longer distribution unaware. A remote class must implement a remote interface. A remote interface must have methods whose headers say that they throw remote exception. Saying that a method throws remote exception makes that interface distribution aware. Okay, so we just can't take existing classes and make them distributed because of this property, because of this problem. Okay. Okay, maybe this code is a little confusing to you, because if you look at, I've said a distributed counter, the class implements distributed counter, the interface. My distributed counter interface says that increment throws remote exception. The method header for increment and the method header for get value say that they throw remote exception. But if you look at the method header in the class, they don't say they throw remote exception. Okay? So there's a mismatch. Is this going to really work? Will Java allow this based on what you know about Java? Okay, so method headers in class do not say they throw remote exception. Are we breaking Java rules? Okay, and so we'll let Andrew's got an answer, and so let's go and hear that answer and others' answers. Okay, so in general, and this is what I'm saying is consistent with what John Ray said and Branson. Sorry, I forgot your name. Nolan. Sorry, and you're Branson, right? Yes. So an interface can be implemented by multiple classes, and those classes can have method implementations that throw different kinds of exceptions. Okay, so here I have a method header interface being implemented by method implementation 1 in class 1 and method implementation 2 in class 2. And one implements a set of exceptions that I'm calling exceptions 1, and the other throws a set of exceptions that I'm calling exceptions 2. And what you have to do in the interface is account for both kinds of exceptions. Okay, because either of these two classes can be used for that interface. Okay, so you have to acknowledge exceptions that are union of the two sets. Okay, and so that's like what John Ray said. It's a hint. It's a hint in the sense that it's a possibility, but it's not guaranteed that it'll happen. And analogy I tell my 401 students is that, you know, in a car you can go and say, look, this is a new driver driving it. Okay, and if that car is driven by an experienced driver, others have to watch out, but nothing bad happens. They just have to be a little bit more careful. Okay, nothing really bad happened. And why would you ever do that? Why would an experienced driver ever drive a car in which we have this false? Because there might be one car being driven by both a student driver and an experienced driver, and we don't want to keep changing the signs each time. So we say that we take the more conservative approach. Okay, it's better to go and err on the cautious side than on the non-cautious side. Okay, so a new driver warning is fine because we're taking the unions of the warnings that can arise. And you know, we see this in medicine also. Every time somebody goes and advertises a good medicine, they have to go and say, oh, there are all these side effects possible. That doesn't mean that everybody will get the side effects. It means that some people have had the side effects, so we'll go and warn everybody about it. Okay, so one person might get dizzy, the other person might not, but we will in that case say that the medicine can cause dizziness. You have to be ready for that. Okay, so that's why you would get dizzy. So we have now a method header and an implementation which does not throw remote exception. Okay, so when the remote class is used directly, we know that method will not throw a remote exception. It's being used directly. Okay, but we also want the method header to apply to the proxy class. And when the proxy class goes and implements that method, executes that method, it might throw a remote exception. So we have to go and say in the interface class, it throws remote exception. And that's all right because we're being more conservative. So it's fine. It's consistent with what Java does. And it's a hint. It encompasses the fact that it can throw an exception and the reverse cannot hold true. Okay, you can't have an intersection. We want a union. Otherwise, some interface user might be surprised. And we don't want such surprises in Java. Okay. Okay, so now that we understand that, let's go and make it a slightly more complicated problem. Okay, so far it's pretty simple, right? You just go and make your interfaces extend remote, and you've got remote classes. Okay, and you have to go and say throws remote exception in all the headers. Okay, that's easily done, and you guys will have to do this in your assignment, by the way, when you do this. Okay, but once you understand what's going on, even if you don't understand what's going on, it's not hard to do so. Okay, so let's make it a little bit more challenging. Here I allow both increment and get value to be called remotely. Okay. What if I want increment to be called remotely but not get value? Okay, let's say we are all voting. Surprise, surprise, I'm thinking of that today. Okay, and we don't want each voter in New Hampshire to go and know what other people have voted. So we want them to vote independently. And so we don't want get value to be called, but we want increment to be called. Okay, there's lots of situations where you might want selective access. So can you guys figure out based on what you have learned already, how to allow local only access to certain methods of a remote class? So I do want some methods to be called remotely, but not all. And I see a hand up. So Branson, I'll let you answer. So what we're going to do is just remove from the interface the method from the remote interface, the method we don't want to call remotely. Okay? In interface, you cannot put the private keyword in it. Any method declared in interface is public. That's why I didn't even say public void. I just said void. Interfaces only have public methods. Okay? And we do want the counters increment method to be called from any class locally. So I am going to keep that public. Okay, so public private will not do it per se, but the idea is similar. Okay, that do you export something outside your class hierarchy? Do you export something outside your package? Do you export something outside your process? Okay, so it's an extra degree of exporting, and we will just create our interface to have the right methods. Okay. So only a subset of classes methods can be included in remote interfaces, which means a class can have local only and remote interfaces. That is why I've kept counter there. So a distributed counter implements counter for the local people and implements distributed counter for the remote people. And even though we have methods with the same names in both interfaces, that is okay in Java. Okay, and so we can have both real and proxy objects assigned to this variable. And when we go and type this variable as distributed counter, we can only invoke the remote methods on it. We cannot invoke the local only methods on it. Okay, that's a side effect of what we said. That's the consequence of what we said. Okay. Okay, so all this assumes that we can magically somehow assign to the counter variable either a remote object or a proxy to it. Okay? Assigning to it a remote object is simple, right? You instantiate the object locally and you assign to counter that object. No problems. These proxies, we know the proxy classes exist, we know what the proxies do, but how do we actually touch and get hold of a proxy? Okay, that is a problem we haven't addressed. And so that is what's going to complicate your code a little bit. Okay, other than creating the remote interfaces, this is the step you have to take. Okay, So, and as it turns out, we don't want you to even know the name of the proxy class in RMI. So you should be able to get an instance of a proxy class without ever naming that class. Okay? And so that is going to be our next question. How does the calling process get a proxy object for a remote object whose class you don't even, remote objects class you might know, but the proxy objects class you don't know because that's generated by Java. And a related question is, how does the calling process ensure that some instances of a remote class are remote objects and some instances are not? We've seen earlier that some methods of a remote object can be called remotely and some not. But we may want some instances whose methods are never called remotely. So I might want a local counter only that just keeps track of some data that I have locally. Plus I want a remote counter that is tallying my votes. I don't want to create two different classes for that. So how do I make sure that certain instances are exported, certain instances are not exported? We've already seen how we can export certain methods and not others. Okay? As it turns out, these two questions can be answered by the same solution. Okay? How to create an instance of an unnamed class and how to go and make sure that certain instances are not exported and certain are. Okay? And we've kind of seen the elements of this solution earlier, so hopefully you guys can answer these questions. So we saw that a name server was basically, as Jason mentioned, we need a factory, but we need a distributed factory, and the distributed factory is what we call the name server. Okay, and the DNS server was an example of that. So a proxy object can be retrieved from a name server, which is a remote factory for it, and a callee can register only certain objects in the name server, only certain instances of the name server. And the instances it does not register in the name server, you cannot invoke remote methods on them. Okay, so that's an extra concept we have to add to make our stuff work securely. Okay, and to make it work in general, we need somehow to get proxies. Okay, so this is how it. This is what happens in RMI. Okay, we have a remote instance. We have an instance of a remote class. We may or may not want to make it a remote instance. If you want to make it a remote instance, we tell Java, do some magic and create a proxy for it. Okay, that magic is done by making a special API call. It happens to be called export. That makes sense, right? You're exporting it out of your computer. Okay. So now you have a proxy in the called process, not in the calling process. So somehow this proxy has to go from the called process to the calling process. Okay? And the calling process is going to have to, so this is going to go to, we know that we want a factory. Factory is a level of indirection, gives you a level of indirection. So it has to go to a factory, it has to go to a name server. That name server happens to be called RMI registry in RMI. It's a name server. Just as DNS server is an example of a name server, RMI registry is an example of a name server. So this proxy has to be registered by the called process, the called process with the registry. Okay? So we need a method called and register, which is a method that does registration, which happens to be called rebind. Okay? Where you go and take the proxy that's been generated locally and pass a copy of it to the registry. Okay? That proxy knows how to go and reach the remote server. Okay? From there, you can look up the proxy from another process. Okay? So we have the export operation that says create a proxy. We have the register operation that says, take this proxy and make it available to other clients. And then the lookup operation that goes and looks it up. Okay? So the lookup and register operations are operations any name server will have. And the export operation is a new operation that is peculiar to proxies and remote objects. So that is the only new concept that we are adding to the general idea of a name server. Okay? And once this is established, any methods that you invoke in the proxy go to the remote object. Okay? The proxy has that behavior. Okay? And the export operation has actually two side effects. It creates a proxy. It also, we saw earlier that RPC can be implemented on top of data communication. Okay, so you need a data communication port to make these calls from the proxy go to the remote object. Okay, and the export object will, if such a port has not already been created, it'll create that port. Otherwise, it'll just reuse the previous port. Okay, the export operation will take a port, will take a number for the port. We'll see what that means. A port number. You guys are familiar with port numbers from the web. You know the web. So this is a very Unix, or well, it's not. It started with Unix, but it now is everywhere. But this is a very OS specific concept. Okay, the multiple processes can listen for messages, data communication messages on the same host, and to distinguish among the mailboxes used by the different processes, we use port numbers, okay, which are global to all processes. So proxies can be retrieved only for rebound exported remote objects. Okay, so the object has to be exported and then rebound or registered for it to be a remote object. Okay. So I said that there are these operations lookup and rebind. You know, in Java, operations have to be invoked on either classes or instances of classes. So the operations are all declared in classes or declared in interfaces. And so the rebind and remote methods happen, and lookup methods happen to be methods in the type registry. Okay, that's just the name that RMI gives. Okay, so RMI registry is the process, and registry is the type of the object on which you invoke rebind and lookup. You don't invoke operations on processes. You don't invoke operations without there being any class or any type associated with it. So registry is the type, and as I've implied or maybe even explicitly said, a name server keeps name object pairs, and actually the RMI registry is totally proxy unaware. Okay, it will, any object that it gets over the network, it will store that with a name. That proxy may be that object may be a copy of a proxy object or a regular object. Okay, and copies over the network are called serialized objects. So it's the serialized copy of either a proxy or a regular object. Okay, it just keeps that binding. And when we go and create a proxy and store it there, then we get the proxy semantics. Okay, and caller gets copy of either the proxy object or the regular object when it does a lookup. Okay, so the registry knows nothing about proxies. This is very important. It just stores serialized objects, which can be serialized proxies or serialized regular objects. Okay. And as it turns out, this rule is kind of inconsistent with what I said earlier, that only instances of remote can be looked up and registered. Okay. And the registry must have this, whatever object you deposit with the registry, it must know about that class. Okay, so for those of you who program in Java, you know that there's a class path that you have to worry about which defines the scope of classes that are visible there. So the class path of the registry process must have all your objects in it. Okay, this is when you guys create the registry, you have to make sure that the registry runs from your project, because if it runs from your project, then it will have your class path in it. Okay. So we have now two questions. Okay, how do you start the server, registry server? Okay, and there's a bootstrapping problem here. We invoke instances of we invoke the rebind and lookup operations on instances of registry. Right? That registry int is actually a remote object. So I'm going to invoke lookup to get a proxy to an object in a server I'm interested in it. But that implies I somehow need a reference to a proxy to the remote registry. So there's a bootstrapping problem. So how do you get proxy reference to the name server? Okay, and in any bootstrapping problem, you'd kind of say, well, we'll just give you a restricted solution that works only for registry. Okay, so so let's go and see how do you start the RMI registry from a program. There's another type in Java called locate registry, and you can go and say create registry, and you can give the port number on which messages to the registry will be sent. Okay, by default, the convention is to use the port number 1099. Okay, so any process can become a name server. I can do 10 other things, plus I can become a name server by just going and saying create registry and give it a port number, and now I've got a remote registry object in me that others can get hold of. Okay, and port is an int identifying a data communication port, okay, at a host. And those of you who've dealt with port numbers, those of you, almost everybody probably knows that the web server is port number 80. Port number 80 happens to be a reserved port by a privileged service. Okay, there are also reserved ports by non-privileged services, and then there is temporary ports. Okay, and when you guys create your registry, you should use 1099. But if you decide not to use 1099, or you should use 1099 for the RMI registry, you'll also need to have port numbers for your servers, and those should not be 1099. Otherwise, there's a conflict. And you should choose a port number that you know is not being used by somebody else. And that happens to be a port number in the range 49152 to 65535. I got that from Wikipedia. Okay, so that's a little detail you need to know. Okay, so we know how to create registry. The next question is, how do you get a reference to a registry in a remote process? For that, there's a get registry method that we can invoke also on locate registry. It's a static method. You can give it the host on which the registry is supposed to be, and you can give it the port number. Again, the port number would be 1099. If you don't give 1099, it assumes to be 1099. Okay, and that's how you get a remote reference to the registry object on the process. Okay, so one process, this locate registry class exists in all processes that use RMI. One of those processes can decide to become an RMI server and do a create registry. Another process can go and do a get registry, and that get registry will go and return a proxy to the object created by the first process, magically. Okay, it doesn't use the same mechanism as is provided for user level servers. Okay, so get registry returns a proxy for an instance of singleton registry. So registry has a singleton in each process that is stored in the process receiving messages on the specified port and host in the create registry call. Okay, get registry call. So create registry will create a registry RMI server on that particular host. So we don't have to give a host name there. Okay, so when creating the registry, we just give the port number. When calling get registry, we have to give the host also, because in general the registry will be remote. Okay. So this shows you some code. Here's my RMI registry starter. All I did was locate registry dot create registry 1099, which again I said was the port for RMI servers, and then I do something that seemed totally orthogonal to what I want to do. So I don't want to do anything else. I'm not going to be a counter server. I'm just going to be a pure registry. Okay, but I'm doing this this read that will never actually unblock. I'm doing this for only one purpose: to keep this process alive. Okay, otherwise the main method will terminate and the process will go away. Even though I said create registry, it's going to go away. So I just did it for that purpose. There are many ways to go and block. This is one way to block. Okay, to just make sure that the main process doesn't die. Okay, so if you guys are going to use a separate registry process, create a separate registry process, this is something you want to do also. Okay, So 109 is the port that is used by default, and this prevents termination. Okay. Often, say I'm trying to create a counter server process, so often my registry will be part of the same process. Okay, so I can do counter activities and I can do registry activities. Okay. That doesn't allow the server and the registry to be moved. So it's not as flexible. So in your assignments, I'm going to require you to have separate processes. But this is a possibility in Java. Okay, because any process that says create registry will become a name server. Okay. You can also just as there's the program called Java in your JDK or your JRE, there's a program called Java C. There's also a program called RMI registry, which takes a port number as an argument. You can run that program directly from the command line without having to go through such a main method to run it. Okay. Okay, so you see here the registry being looked up. So here's my counter client. We haven't seen the counter server so far. Let's assume by magic it does the right things. The counter client is going to first go and get the registry. In this get registry call, I don't specify the host, I don't specify the port. If I don't specify the host, it looks for a registry in the local host. Okay, so that's what I did. I'm just, to make my program short, I just omitted the arguments. If I don't specify the port, it will use the port number of 1099. Okay, so I first get a reference to this registry. I've got that, RMI registry. And then I get from that RMI registry reference, the reference to a counter. Okay, and I'm assuming the server used a particular name for that counter. I remember there's a name associated with each object that's registered. I'm assuming it is the name of the class, the class of the counter. I'm assuming that there's only one instance of that counter, and that the class name is the same as the instance name. I can put any name there, but I'm assuming the server went and used that name. Okay? And then I can do operations like increment and get value on that counter. So you see that I've got two ways. I've got this particular call that gets a proxy, and default host is localhost and default port is 1099, like I said before. And I've got another call to get the proxy to the real object I want. Okay, and these two calls are different. Okay, because of the bootstrapping problem. Okay. So this is how you get access to proxies. Two different ways to get references, one for bootstrapping. So, as I said earlier, RMI registry just keeps objects in it. If it gets proxies, it stores proxies. If it gets non-proxies, it stores non-proxies. Okay? We know how to get any object from RMI registry. Okay? So the question we haven't answered is, how does the called process store a proxy in the server? Well, that's easy. We go and call rebind. Okay, and we've also seen export. So that's what we are seeing in detail now. We saw that conceptually. We've seen this in detail. There's another object called unicast remote object. There's another class there, and you can say call export object on it and give it again a port number. This is the port number in which messages that contain calls to the remote object will be sent. Okay, so I'm trying to export this object that is typed as remote, and messages to that, calls to that object will have to come through some data port. This is the particular port through which the messages will come. So the same server can have objects distributed among different data communication ports. Okay, so that's the flexibility you have. So that's the call. So it creates a proxy for an object and stores it in a global system table. So what export object does is creates a proxy and associates this remote object, this object that was exported, with that proxy. Okay, and if you don't specify the port number, it uses a default port. And export object will give an exception if the object does not correctly implement a remote interface. Okay, we saw that too. So we are seeing that that call being invoked here. Again, the server, just like the client, needs first a reference to the registry. Okay. Again, it just does get registry, and again we are assuming the registry is on localhost. It's a 1099, so I don't specify any arguments. Then this particular server creates a remote instance. Okay, so we've set a new distributed counter. Okay, that instance at this point does not have a proxy associated with it, and nothing has been sent to the name server. Okay. Now we go and say unicast remote object export object counter comma 0. We're saying, hey, just choose some port from the temporary port range there is. I don't want to specify that port range. Okay, just use anything that's unallocated. Okay. So at this point, I have a proxy associated with counter. There's some table in the server that stores the association, and the server, when we go in now say rebind, and I'm giving this name, the class name, I say distributed counter.class.getName, the same name the client used, and I'm giving the counter object. Because there is a proxy associated with the counter object, what is actually sent is not the counter object, but the proxy object. Okay, this is kind of unintuitive, and you might make mistakes here. Okay, but rebind will look up that table and say, do I have a proxy associated with this particular object that is being rebound? If I do, I will not send the object itself. I will send the proxy object, and whatever object I send, of course, will get serialized before I send it. Okay, and you can invoke local operations on this too. So I'm saying invoke increment on my counter. Okay, and that's fine. I can invoke the operations locally on that object, and I'm printing out the value, and the counter is initially 0. I go and say increment 50, so I will get an output of 50 at the server. Okay. So these are details. What I really showed you in the picture where the proxies travel around was the concept, but these details are important for your assignments and to get things working. Okay. Here's my client code again, and now we're going to understand what's happening. Because an export object occurred, we are getting a reference to the proxy, and the counter will increment. The counter will get. The client will look up the counter. The counter's count value is 50 when it does the lookup. It does counter.increment minus 25. So this proxy is referencing the same counter that the server had. So I should go and get the value of 50 minus 25. Okay, and not 0 minus 25. I didn't get a copy of the counter object at the server end. I got a proxy to it, so we are referencing the same object. Okay. Okay, so I've spent some time there explaining what is to be done. And many of these things are details, and whenever something is a detail, it's easy to go and make a mistake. Okay, when something is a concept, it's you're more careful. When something is a detail, you tend to make mistakes. That's why most accidents occur when you're driving back home, because you say, "Oh, I know this terrain," so you're absent-minded. When something is challenging, you pay attention. So whether it's called unicast remote object or what, something else, you might forget and make a mistake. Okay, and also it's good to look at variations of this code that are meaningful. Not only variations that are erroneous, but correct also. So let's go and look at some variations to better understand what we've really done. So this is a legal interface in Java. I can say distributed counter extends remote, and I can say get value throws remote exception, but increment does not throw remote exception. I don't have to have each method header say throws remote exception at compile time. Only if I go and export an instance of this object does this matter. Okay? So if I do this, if I try to do an export, I get an exception rather than a compile time error. Okay, at export time, I will get a little message saying, illegal remote method encountered. Okay, and you guys might get this message, and this message may or may not tell you what you did wrong. Okay, but this is what you did wrong. You forgot to go and say throws remote exception on the method that it's talking about. Okay, it just says illegal remote interface. The object illegal remote interface and illegal argument exception. So I think by just looking at this, you might not be able to figure out what the problem was. Okay, so that is the problem. Okay. So again, as I mentioned, that when you do an export object, it gives an exception if the object does not correctly implement a remote interface, and that is the reason why you got this exception. Okay. Okay. So in that previous example, I forgot to put throws remote exception in my remote interface. What if I forget to export object? What if I say rebind and not export object? Okay, what happens then? Well, I told you guys that if you don't export the object, we will send a serialized copy of the remote object directly, not a serialized copy of the export proxy, but the object. But as it turns out, that fails. I get an exception saying not serializable exception. Okay, and can you guys see how this message is consistent with what I've said so far? So as Jason said, that object is not serializable, and RMI registry is trying to serialize it, the object itself, and the export object created a serializable proxy, which was successfully sent to the RMI registry. In the absence of a serializable proxy for the exported remote object, rebind tries to serialize the remote object directly. Okay, and we saw earlier that not all objects should be serialized by default. Okay, system.in, thread, files, text fields. Okay, it is sometimes possible to send a serialized copy, but it's not meaningful to do so. Okay, and it's not meaningful to do so because there's location-dependent semantics. The OS at the other end may not have the capability to go and create that object, or may not know how to create an equivalent object, and so these are things that can't be serialized. So how does Java know that this object it is meaningful to serialize and or not? Okay, it's conservative by default. It says by default programmer defined types are not serializable. Int, strings, arrays are all serializable. Okay, but any type you define is by default not serializable unless you tell Java, yes, I want it serialized. Okay, and this is a rule that you really need to know. An object is considered serializable only if two conditions hold true. Its components are serializable. Components are values assigned to its instance variables. This is a recursive definition. Its components have to be serializable, and it has to say it implements the serializable interface. The serializable interface, like the remote interface, has no methods in it. So it's not as if you have to implement any extra methods, but it's just a label. When these concepts got invented in Java, there was no annotations. Today with annotations, you would do it differently, I believe. But this is legacy software. So you're just labeling an interface to be serializable. And when you do that, you're saying, Java, please use your default serialization mechanisms to serialize my objects. I do want them transferred. Okay? So when we try to go and export this object, we go and look at distributed counter. A distributed counter has the variable value, which is a type integer. Integer happens to be serializable. So the first condition holds true, but the distributed counter itself does not say that it implements serializable. So the first condition is true, the second condition is not true. Okay, so that's why we got the exception. Okay. And how to get rid of this exception? I will now create another interface. I'll keep the distributed counter around because I want to use that in examples. I will create a serializable counter interface that extends distributed counter and serializable. Okay? And I will create a serializable counter class that just extends distributed counter, and all it does is put the label serializable on it. No new methods had to be defined. All you did was say mark it as serializable. Okay? So now I've got a separate class called serializable counter, a separate interface called serializable counter, no new method headers, no new method implementations, just labels. Okay, that's why I use the word implements in quotes. We're not really implementing any new methods, we're just saying we want to have this behavior. Okay? And now, if I don't export the object, but I create instead an instance of a serializable counter, things work. Okay? I get no exception. Okay? Okay, let's try to understand this even more. I've got serializable counter. You guys might have seen the notion of delegation versus inheritance, where you can delegate to another object, another class, when you have a reference to an instance of that class, rather than inheriting from that class. So I'm trying to go and create a serializable delegating counter, okay, which is going to delegate its work to another object. That object is of type counter. So it's got the increment and get value methods. It doesn't do anything with these methods. It just forwards these methods to the object that was passed to it in the constructor. That's why the word delegation here. I'm just delegating the work to somebody that I got. Okay? And I can get here a counter. I can be passed a distributed counter, or I can be passed a serialized counter. Okay? But I'm saying I implement the serializable counter interface, which means I implement both the distributed counter methods and I implement the serializable methods. Okay? So you guys understand this particular class? What if I go and register an instance of this wrapped counter with the RMI server and I don't do an export object? Will I get an exception or will I not get an exception according to the rules that I've given you? Okay. And as it turns out, I get an exception. Okay. And the question is, why did I get an exception?
Is that because counter isn't serializable?
So again, there are two properties. Its components should be serializable and it should implement the serializable interface. The second property is true. Okay? The counter, this particular class does implement the serializable interface. But as Andrew pointed out, the counter object that it stores in its instance variable happens to be a distributed counter, not a serializable counter. A distributed counter is not serializable, so again we get into an exception because the components are not serializable. Okay? Now in your project, you have to go and pass key value instances across the network. You have to also pass maps across the network. Maps happen to be serializable. Your key value types are defined by you. So you'll have to make sure that those key value types are serializable. Okay, and I tell you to do that actually. But this is, I need to bring this out so that you can do the assignment. Okay. So, like I said, the components of the class are not serializable. Okay. So, let's go back and compare two solutions that are correct. One solution that's correct happens to have export object in it. The server went and created a counter, then set increment 50. After registering the counter with the name server, it set increment 50. Okay? And the number printed here was 50. That makes sense. And in the client, because the client was sharing the object, when it did minus 25, it got 25, right? This was one correct behavior. Then we saw a lot of wrong behaviors, and we saw another correct behavior where we actually went and said, did not export the object, but did a rebind on serializable object. Okay? And again, we did the rebind first, then we went and did the increment. Okay? And the server changed, but my client did not change. So my question is, so the server will still print the number 50. Okay? And the question is, what will the client print? So the server will print 50, like I said. We did not export the original object, we exported a copy. After we exported the copy, we went and did an increment of 50. Okay? So the server increment and get value invoked on the copy, not on the, there's no proxy there. So the serializable copy is sent if object is serializable, and increment action will not be seen by client. So as Jason mentioned, you will what the client will get is a copy of the original registered object. At that point, the counter happened to be 0. So it'll print out minus 25. Okay? That 50 was not seen by the client because it was done on a different copy than the one the client has. Okay? So these are all things that can go wrong if you just miss out a few lines. Okay? And again, you should understand what's really going on underneath to know why what you did was wrong. Okay? So RMI is not hard to use. I mean, I've had 401 students who want to do distributed computing with me. I said, just go read up on RMI and use it, and more or less it works. But when it doesn't work, you need to know a little bit more what's happening under the hood to understand what the problems are. Okay, that's why. I mean, you should, in general, as computer scientists, know what's going on under the hood, but you should also know it to get things to recover. Okay, let's talk of termination issues now. Look at this main method. The main method went and printed out server :50, and the main method finished. So if the main method finishes, does that mean that the server also terminated? If the server terminated, how can the client go and affect things, server objects in the server? Okay, because we have sent out a proxy to an object. That proxy is going to invoke methods on a remote object that is stored in this process. This process has executed a main method, and the main method is over. Yet the client worked. So what's going on here? So the main thread finishes after output, yet the server does not terminate yet. And why? What can we learn? What can we learn about Java from this? Or what does it say about Java? And this kind of problem, if you ever build a GUI, this kind of issue has arisen there too. Okay. So there is some piece of code here that causes Java not to terminate the process. And the two new things we've seen here are export and rebind. Okay. So one or both of these actions together made the process not terminate. And Andrew's right, it's the export. Okay, if you do the export, you create a proxy, you're creating a data communication port, and so that means you need some way to listen to messages on that port. So that is what happens. And if you ever done a GUI, build a GUI and create a frame, if you create a frame and don't set it visible, the program will terminate when the main method finishes. But if you create a frame and set it visible, then it tells Java, please don't go and terminate the program. Allow the AWT thread to go and service requests that have to do with the frame, and it will not terminate the process. Okay, so you may not have thought of this explicitly, but if you ever created a frame object in a main method, the program will not terminate. Okay, so that's the answer. Okay, And you see that here, there's no main thread, but the server is still the server is still running. Okay. So export object causes to not terminate. And if I did not do an export object, as is the case here, then the server will just terminate. Okay, it's passed its copy away. Okay, that copy can't be referenced, so the server just goes away. Okay. Okay, so let us review aspects of RMI we saw last time. We saw that we have the notion of a call process or a callee process, and we have notion of callee processes that call methods in call processes, and they get in touch with each other through a name server, and the name server is called RMI registry in RMI. So that's the process RMI registry, and it also has registry objects in it. Okay. So registry object is what you're seeing here. It has a lookup and a rebind, which is basically a register function, and the caller invokes a lookup function, and the lookup function returns something that was registered or bound by the callee. Okay, so that's the basic name server functions. A name server is essentially a factory that is remote. And then the question was, how do you get a reference to the registry object? How do you get a proxy to it? So that's a bootstrapping problem. So there's some static methods that you can execute on a static class called locate registry, and you can use a static method to actually create a registry object in any process. Okay, so that process then becomes a RMI server, and once a registry object has been created in some process, a remote process can get a reference to it by invoking get registry. Okay, so create registry creates a registry and makes that process a remote RMI process, registry process, and get registry helps you get a reference to it. Okay, so that's what this is showing, and both the caller and callee need to get a reference to get registry before they can do the rebind and lookup. Okay, and the registry can just stores copies of registered objects, and those objects could be real objects or proxies. And if you want to convert an object to a real, if you want a proxy to be registered with the registry, then you must export it first. Okay, so exporting the object creates a proxy, and then the next rebind, the rebinds after that will go and register proxies for that object rather than the object that was really passed to rebind. Okay, so rebind takes a name and an object as an argument, and if the object has been exported, then the object is not registered, the proxy is registered. Okay, so this might be a little confusing. It's important to understand this. Okay, so it's the callee that exports the object and creates a proxy. Okay, which is then sent to the registry, and from where it is retrieved by the callee. And since we are talking about a network, we can have remote exceptions. Okay, and so when we invoke a method on a local proxy, it is as if we invoked it on the remote object, except it goes over the network, so it may be slower, and it might have errors that would otherwise not occur. Okay, those errors are given to the caller as exceptions, and specifically remote exceptions, which are checked exceptions because these are not under the control of the program. Okay, so the method call must catch the remote exception because it is a checked exception, so it must catch it, and the checked remote exception occurs if any distribution error occurs. Okay, and the reason it's checked is because it's not under the control of the programmer. So not all methods of a class are going to be available to the world, to other processes, just as not all methods of a class are available to classes in the same process. It's even more important that not all methods be available to remote processes. Even if they are public, they're not necessarily available. So you can label methods as remotely invocable, and the labeling is done through a remote interface. So you put all the methods that you want to invoke remotely in remote interfaces, and it's only those methods that will be invoked remotely. Okay. So if an interface extends or class implements the remote interface, then every method in the class interface is labeled as remote and is expected to have a throws clause in its header. Okay. And if such a clause doesn't exist, then when the object is exported, you will get an error. Okay, so this is all we talked about last time, and just summarizing it using different slides. And for your assignment, you will need to actually call these methods. And when I showed you the slides, I didn't show you the packages in which these classes exist. In the assignment, I have mentioned what the packages are. But here's a summary of all the methods along with the packages so that you can find them easily. Okay. And all the code I'm showing you in slides is in my Git repository that I have referenced in the class material. So feel free to go and get the Git repository and search for the classes in the Git repository. Okay, there's a file menu. In that file menu, you can go and just type a class name, and it'll find the class name in your whole package. So you don't have to know the package name. Okay, so this is all abstract. We all want examples to sort of really understand what's going on and to use as templates when we do our assignments. And the example I took was a counter example. Okay, I began with just an interface counter that was meant for local usage. Okay, it had the increment and get value methods in it. But these methods, since they were meant for local usage, they don't say they throw remote exception. So then we created a distributed counter that extended remote, and then it has the same method headers, method signatures as counter does. Okay, by method signature I mean the name and types and return value, name and parameter types and return value. I don't necessarily mean the throws clause. Okay, so signature plus throws clause is equal to the header. Okay, so my distributed counter, basically I copied the headers from counter and I put the throws clause in there. Okay, my distributed counter now implements both counter and distributed counter. Okay, and so all the methods in distributed counter can now be invoked remotely. So basically both methods, get value and increment, can be executed remotely. And we saw that it's possible for the header methods to throw fewer exceptions, for the class header methods to throw fewer exceptions than the interface header methods. Okay, we saw why last time. And a distributed counter is implementing an interface both for local usage and remote usage, and they don't have to have the same signatures. So I can remove from distributed counter, say, the get value method, and only export a subset of the public methods to remote use, remote processes. Okay. So in the previous slide, I'm not quite sure what I'm trying to go, where I'm going next, but I think what I want to say is the following: that I went in my distributed counter class. If you remember, I don't want to go back to the previous slide because I will lose the recording. I duplicated all the methods in a counter. Okay, so my counter was this. It had integer value equals 0, public get value, public increment, and what I did was, but it did not implement distributed counter. Okay, so what I did in the previous slide was I created a new class, a distributed counter, where I copied all the methods in a counter. They were identical. There was no changes to the methods, and all I did was change the implements clause. Okay, and I did that because I wanted to show the relationship between the method headers and the interface, the class headers and the interface headers. But I needn't have done that. I could have just gone and done the following. I could have just said a distributed counter extends a counter, implements distributed counter, and that's enough. Because by doing so, I've labeled it to be a remote class, a class that implements a remote interface. So I needn't have gone and copied all the method headers. Okay, so if in your project, you're welcome to go and change the existing classes. You don't have to keep the original classes. Okay, but if you want to keep the original classes, you might want to just inherit from them. You needn't go and duplicate the code. Okay. And it's not enough to just go in. So that was pretty simple. And RMI is simple once you know the rules and the rationale. But what I said earlier was not sufficient to create a distributed program. You must also, as the pictures before you showed you, that once you have a remote class, you must go and export it and rebind it with a registry. So this shows you how to make a regular process that is standalone into a server. Okay, and that's a task you also have to do in your assignment. You have to take your A2 process and make it into a server, and you'll do something like this. Okay, and then you also have to create now a client process, and the client process has to go and again contact a registry, just like the server process has to. And then it has to just do a lookup, and once it does a lookup, it has the proxy to it, and it can do all the things that the remote interface allows it to do. Okay, and not enough, you also have to have a name server, and that name server can be part of your real server, can be part of the counter server in our example, but it's more flexible to have it as a separate process. So this shows you how to go and start the RMI server process. Okay, and you're not really, all you're doing is starting a piece of code. So there's nothing conceptual here, except you have to know the details of this call. Okay, that goes and does create registry, put a port number there, and we stop it from halting, the main method from halting. Okay, this is all review because we're going to build on this example, and so I need this example to be in your cache. And this is how we're going to build on this example. Okay, you can think of a server and a client to have the same relationship as a low-level layer and a higher-level layer have. Okay, a higher-level layer knows about the lower-level layer, but the lower-level layer does not know about the higher-level layer. Right? That's the awareness thing we want. Similarly, a server. So far, we've only been talking about calling processes and caller processes. But now let's talk about some processes being servers and some being clients. Okay, by having some processes being servers and some being clients, we reduce the dependency among processes. Just as if you take two modules and put them in different layers, we reduce the dependencies among them because certain modules can be unaware of other modules. Okay, so let's go and see how we can have calls among processes while reducing awareness. Okay, so why would you need two-way calls? Remote calls from one process to the other process and vice versa? Well, our observer pattern calls for that. Okay, so what we've seen so far is a way to create a remote observable. Okay, that say in a server on which an observer can invoke methods. Okay, so we get an observable proxy in the observer process. The remote observer invokes methods in the observable proxy, which forwards the methods to the actual observable. Okay, so the observable can be in a server, and the observer can be in a client. Okay, what if what if the observer pattern also requires the observable to be able to send notifications to the remote observer. Okay, so how do we allow that to happen, given architecture? And those of you who've done any web programming, you know that basically such a pattern is not supported. The client process has to keep polling the server to figure out if there's any new information or not. So you don't have, in the basic HTTP servers, the ability to do callbacks. Okay, we'd like to have callbacks, and given what I've told you, how do we create such callbacks, and what should we do? How should we improve on those mechanisms to reduce the awareness? That's the question those are the questions we're going to answer. Okay, so given that what I've told you, this is what we could do to create the two-way connections. Okay, I will create a remote observable. I can export it. So now I have an observable proxy. Then I go and I have another module in my program that is an exporter that goes and sends the proxy to an RMI server. So it stores the proxy there. From there, an importer in the client can go and look up perform a lookup and get a local proxy, and that proxy can access the observable. Okay, and the remote observer can invoke methods on the observable proxy. Okay, so that's one-way connection. That's what we've seen. To do two-way connections, we just repeat the steps, but we change the roles. Okay. Now I go and have the observer process do an export and create an observer proxy, have an exporter in it that goes and binds it to the server. The server now has the observer proxy also, which can be looked up by an importer in the observer process. And so now we have the proxy here, and we have the two-way connection. Okay, this is what I could do. Okay, this is what I don't want to do, because both have awareness of each other. Okay, the observer process needs to know what name each client has has registered its observer proxy as. It has to be aware of the fact that of each of the clients, and so essentially we have the analog of the situation in a local case, where there are two modules connected to each other and they're not in different layers, and we'd like to have them be in different layers. Okay, so we want one of them to be the server, the other to be the client, which means the lookups are done by the client and not by the server, and the rebinds are done by the server and not by the client. Okay, so that's what we'd like to do, and this is what we have. And the question is, how should we go and change our architecture? I mean, if you were an RMI designer, what would you do to go and allow asymmetry? Okay, symmetry is normally considered good, but in layering and awareness, we want lack of symmetry. We want asymmetry because we want less awareness. Okay, so how to get proxies in both processes using one-way awareness? And the hint is, we already know of a solution in the local case. We do know that we can go and invoke methods from lower level layers to upper level layers and vice versa. Okay, we've already seen how that happens. So can we use some similar principles to allow two-way calls and yet have one-way awareness? Okay, and the hint I'm giving you is, let's go and think of extending what we know in the local case to the distributed case also. Okay, so that's your question. Okay, so like both Jason and Randy mentioned, you essentially want the higher level layer to pass to the lower level layer information about how to call itself. Okay, once the higher level layer or the client connects to the server, it can go and tell the server about its proxies rather than have the server go to some factory to get references to it. Okay, so the idea of a callback exists in the local case. A callback is a function that is passed as an argument to another function. Okay, it's a higher order function. So the higher level layer invokes a callback in the lower level layer, invokes a method in the lower level layer, passing the lower level layer a callback, a pointer to the method in itself. Okay, so the reference is pushed to the lower level layer. The lower level layer doesn't have to go and pull the information. Okay, just as you might leave a number on an answering machine. So what we'll do is, we'll set up the architecture as we did before for the observer, for the client to server connection, which in this case means the observer process to observable process connection. And we will go and have the remote observer invoke a register method, passing itself as an argument, and this register method is invoked on the proxy. Okay, and I'm talking register in very abstract terms because I'm talking the observer pattern. But if we're talking about a bean object, okay, which is what we are dealing with in our implementations, then that register method is basically our add property change listener method. Okay, so it will call an add property change listener method on its proxy that it has, passing itself to it. Okay, and what this will do is, since the remote observer is now implements a remote interface. Okay, the system knows that it implements a remote interface. So it goes and says, oh, you want to pass yourself, but sending a serialized copy of you it doesn't make sense. So what I will do is, if you exported the object, okay, so the remote observer exports itself, creates an observer proxy, and if the object has been exported, what gets sent is the proxy rather than the object. Okay, just as rebind, when you do rebind of an object, the object doesn't get sent. A proxy to it gets sent if the object has been exported. Similarly, if the object has been exported in this case, when you invoke a method on it, on a proxy, okay, then the proxy of the calling object is sent. Okay, and so when the method is invoked on the remote observable, the side effect of it is that the observer proxy gets stored in the process, in the receiving process. Okay, and so the remote observable gets a reference to the proxy. It gets a copy of the proxy. The proxy is stored in that process, and now it can make invocations on the proxy to talk to it, to talk to the original object. Okay. So what is happening here is not very different from what happened when we did rebind. Remember, rebind was called on a proxy to the registry object. Okay, and that rebind, when called on a proxy, went and sent a proxy of the object being rebound. Okay, so this is sort of proxy being sent to a proxy. Okay, that's what's happening here too. And that works as long as the original object implements remote and has been exported. Okay. So so my animation is a bit off here. So this is a summary of the two approaches. If two processes need to invoke remote operations in each other, in the symmetric approach, each process registers proxies for its remote objects and looks up the proxies for the other's remote objects. Neither of them is a client or a server. In the asymmetric approach, the server registers proxies for its remote objects and the client looks them up. One way that happens. And the client directly invokes calls and remote proxies, passing as arguments exported remote objects. And the parameter passing mechanism, okay, automatically sends exported proxies for the remote parameters and return values. It works for return values too. So short-circuiting rebind and lookup. So you don't have to do a rebind or lookup. So in your project, you're going to have two-way communication. Okay, clients are going to invoke methods on the server saying, hey, we can do tasks for you. So they're going to register themselves, and the server is going to say, okay, I have some tasks. Hey, clients, do the tasks. Okay, so there's two-way connection, just as in the observable observer case. Okay. So let's go and try to apply these ideas, and we'll do it in steps. I'll give you some wrong ways to do it, and we'll try to improve this based on your understanding of what I've said. Okay. So I have originally, I'm going to have now, I had the counter interface that I showed you earlier. I'm going to create an observable counter interface that has the add property change listener method in it. Okay, which takes as an argument property change listener, and this is the observer interface. Okay, this is something you guys have dealt with in assignment 1. So I'm going to have a distributed observable counter that extends my original distributed counter. Okay, so I had a counter, then I extended a counter with a distributed counter, which went and implemented a remote interface, and now I am extending that distributed counter to create a distributed observable counter. Okay, and I'm going to implement the observable counter interface. Okay, so to do that, I'm going to use what you guys have probably used, what I recommended you use, the property chain support object that's provided by Java. Okay, and I'm going to have an add property change listener, a registry method, which takes a property chain listener as an argument, and I don't want to keep the list myself, so I go and store the list in the property chain support object. Okay, so I just go and forward the methods to that. Okay, and my increment method now is going to, since I'm extending a counter, I can just do super.increment to actually change the value, But since I'm an observer, I need to also store the old values and then send an event announcing the old and new values. Okay. So I'm going to do that a little indirectly. I'm going to call a process property change method, and I'm going to pass the event to that. And what does that method do? It just goes and forwards the change to the property change support object, which goes and sends it to all the registered listeners. Okay. So this is going to be important because this is not going to work, and we're going to extend it. So it's kind of important you know the levels of indirection I have here. Okay, so you have property change support that actually stores the listeners, and we have the increment method that goes and creates events and passes it to them. Okay. So the distributed observable class extends a distributed counter, and I'm going to argue that this doesn't work. All my observers need to be local, even though I am extending a distributed counter. All my listeners need to be local. Okay, and why is that? So my counter is not a remote interface. Okay, and so my add property change listener is not a method in a remote interface. If it's not a method in a remote interface, it cannot be called remotely. Okay, because it's not a method in a remote interface, it needn't say it throws remote exception. So we are sort of making two wrongs. We are not saying it's a remote interface, and so we are also not saying that the property change listener can throw a remote exception. Okay, so that is the problem. Okay, add property change listener is not declared in a remote interface. Okay, that's a very simple problem, and this is something that you guys will have to deal with when you create your programs. Okay, so now I can go and do the following. Let's say I had originally an observer, like a counter view, that implements property change listener. That means it has a method called property change that takes property change event as an argument, and let's go and say it just prints out the string. Okay, just as your programs did. So now, as David suggested, I need to go and create for a callback, I need to create a remote interface at the client end also. So I'll create a remote property change listener that extends remote. Okay, and I will have the same method that I had in property change listener, except that it now will say that it throws remote exception. Okay, this allows my call to go the other way also. And now my observer can be a distributed counter, which is a distributed counter view here, will extend a counter view. Okay, so it will do whatever it did, and it will also say that it implements remote property change listener. So now it is a object on which you can invoke remote methods. Okay, so I've got that part going. Okay, and I'll also have now a distributed observable counter that extends distributed counter, and I'll have now an add property change listener that takes as an argument a remote property change listener rather than a property change listener, so that and this should actually say throws remote exception. Okay, so I need to correct this. If I forget to do this, just remember that I need to have throws remote exception. Okay. So I've got now a class that is approaching what I want but hasn't quite reached it. Okay, this class also has problems. Okay, but what I've done is I've taken a distributed counter and I've extended it to create a distributed observable counter. So this is what I had, right? So this is the class I had, and I need to change this class. Okay, this is the class that didn't work earlier because it implemented observable counter, and an observable counter did not have the add property change listener. So now I will extend this class, okay, since I already have this class, to create a distributed remotely observable counter. And I will say I implement a distributed observable counter, and I will have an add property change listener method in it that implements the interface method. Okay. So let's go and understand what's going on here. I have the previous class I had, which didn't quite work for me, so I'm creating a new class. Okay, that new class now has a second property change listener. The first property change listener takes local listeners as arguments. The second property change listener takes remote listeners as an argument. Okay, these are two different types. One of these types has throws remote exception. The other type doesn't have throws remote exception. Okay, and what I'm doing is I'm saying, okay, whatever argument I get, I will go and add that to the list maintained by property change support. Okay, and we know now that we have fixed that one problem we had, that add property change listener was not throwing a remote exception. It was not in a remote interface. I put it in a remote interface and it's throwing a remote exception. So I fixed that problem, but I haven't fixed all the problems. Okay, so what's wrong with this code now? Okay, so I'm good here. I'm good here, okay? And the key is the add property change listener method here. Think about that method. We will get both compile time and conceptual problems if we have this code, and the question is why. Okay. So the problem is property change support stores instances of property change listener. And as Adi mentioned, remote property change listener is not a property change listener. Okay, that method is not able to go and catch remote exceptions. Okay. So this and so when it goes and says property change support dot file property change, that file property change method must be a local method. Okay, the file property change will go and call property change method in the observers, and that method must be a local method. Okay, so it does not catch remote exception. And the fundamental problem we have in Java is that we cannot make existing classes remote classes because of the checked remote exception requirement. Okay, I'll talk about Gypsy later, which is a system I built, where I say that, hey, we'll cheat on the remote exception requirement, the checked remote exception requirement. And if we cheat there, life will become much easier in other ways. Okay, I'm not saying we should cheat. That's why I'm using the word cheat. But it's just that requirement is preventing us from using the class directly. Okay, so I want to make this code this comment about reusability. Okay, so what we'll have to do is we'll again go and extend a distributed observable counter, but we'll go and keep our own list of remote listeners, which is a list of remote property change listeners. Okay, so I will now, whenever add property change listeners called with a remote object, I will store that object in my list, which is distribution aware, rather than in the list kept by property change support, which is not distribution aware. Okay, so this whole distribution awareness thing becomes a very crucial thing in our thing. So whenever the increment operation goes and says process, the increment operation creates a property change event and then says process property change. Okay, that event should be sent to both local observers and remote observers. Okay, so I'll do super.process property change to send it to the local observers. Okay, and I will go and then go through my remote listeners and call the property change method on the listeners that I've kept for the remote case. Okay, so the details here are not as important as the fact that I had to redo code. Okay, so redoing code in property change support. And if you're a designer of a language, you might want to say that, either you get rid of this remote exception requirement, which is not a good idea, I'm saying, but either you get rid of that, or if you're really serious about creating distributed programs and creating distributed observers, then why not change property change support to allow both local and remote observers? Okay, it could easily have property change support implement an interface that extends remote, in which case it could be invoked both locally and remotely. Okay, So this just shows you that the current version of Java is not as supportive of distributed objects as it could be. And that's why we have to go through this whole process. And this is why you might have to go through such a process also when you change your code. Okay, you're also changing code to make it distribution aware. So this is something that happens a lot. Okay. Okay, so we now kind of understand the general approach I talked about earlier. And I want to now focus on what I have in italics, where I said the parameter passing mechanism automatically sends exported proxies for the remote parameters and return values. Short-circuiting, rebind, and lookup. Okay, let's just focus on this a little bit and try to understand this. What's going on underneath, and how does this relate to anything we know earlier? Okay. So what's exactly happening? We have a parameter passing mechanism that's given a parameter to send, and the question is, what should it do with the parameter? It can't just push it on the stack and be done with it. Okay, something has to be sent over the network. What should be sent over the network? Okay, so it goes and says, is that object an exported remote object? Okay, it does that check. If it is, it sends a proxy. Okay, if there's an exported object, there's some local table in that process that has an association between the object and the proxy and vice versa. So it says, okay, let me look up the proxy for this object and send the proxy. If it is not exported, it says, is it serializable? Okay. If it's serializable, then it creates a copy of the object using the serialization techniques we talked about earlier. It might use JSON, it might use something else, but it sends a serialized copy of that. And if it's not serializable, you get a not serializable exception. Okay. So again, proxies are generated by callee process through export in RMI. And only remote instances can be exported, okay, as I've said many times. So you see that parameters can be passed differently. Okay. And those of you who've done programming languages, some of you have done it with me, some of them might have done it with Diane. Have you seen similar alternatives in local parameter passing also? Okay, in remote parameter passing, we can send a proxy or a serializable object. I'm going to argue that analogs of these two concepts exist in local parameter passing also. Okay, so think about an analog. So you guys who've sort of grown up on Java and C++, you don't see this concept very much, but having grown up on other languages like Pascal, there was a notion of, and even in C++ and Java, you know, depending on whether you have a primitive value or an object value, you have two different things happening. Okay, so either a copy or reference to a parameter is passed, which is determined by call by value or call by reference, which is what Jason talked about. Okay, and in some cases, the decision is made automatically based on whether it's an object or a primitive value. In a language like Pascal, you could go and say var parameter or not var parameter, in which case var parameter means passed by reference and not var meant passed by value. Okay, and there the problem was that, you know, there was no real headache there. It was the address or the value just existed in memory. You didn't have to do any work to create them. Okay, in remote method parameter passing, you can't just pass the memory contents directly. You have to either serialize the object or serialize a proxy. Okay, and the question is whether you have a proxy or object. But basically, think of a proxy as a remote reference. Okay, and the regular object as a copy. Okay, so it's actually a very similar concept. Okay, and this brings me to sort of again makes me revisit the idea of serialization versus marshaling. Okay, we said this, objects can be serialized whether they are passed in a data communication link or through remote procedure calls. And marshaling is a concept we see only in remote procedure calls. Okay, and I also said that, look, at one time there was no different separate serialization layer. We only serialized when we're making remote method calls. Okay, you either send bytes on a data communication port, or you send non-bytes on a remote procedure call. Yeah. So Java was probably, to my knowledge, the first language that allowed serialization to be separate from marshaling. Okay, marshaling was built on top of serialization. And Java, as far as I know, is the first language to support this remote references. Okay, so now marshaling doesn't have to just go and take the values on the stack and serialize them. Just give it to the serialization layer, which means it's kind of dumb. Okay, all it's doing is doing a special case of serialization. It has to do things that serialization doesn't do. It has to go and say, oh, is this a proxy? If it's a proxy, let me look up a remote table, a local table, and find the remote object that corresponds to it, that's stored locally, and then pass. Sorry, what it does is it goes and takes the object and sees whether a proxy for it exists or not. It goes and looks up the proxy, and then it sends a proxy, and which is then received by the remote layer. Okay, so it has to do this extra step. And as far as I know, Java is the first, as I said, language to do this. So historically, what happened, as far as I know, is that I mentioned this thesis from Carnegie Mellon on remote procedure call, and in that thesis, the idea of marshaling and unmarshaling, as far as I know, was introduced. Okay, so he went and talked about creating an isomorphic copy at the other end. That's where I learned it from. This guy called Bruce Nelson. It was a theoretical thesis. He didn't do any implementation. He went to Xerox. Xerox is a place that creates copiers, but you may or may not know that Xerox has created many of the concepts that we use today. And he implemented a very simple version of RPC where only primitive values were passed. Even though he had all these algorithms for passing isomorphic copies of objects, he didn't really implement them. And then I saw another paper from either his group or some other group that said, why would you ever go and send serialized objects? Because we've looked at programs, they only send, why would we send non-primitive values? But we've looked at programs, they only send primitive values. And it's a chicken and egg problem. If you don't make it easy for me to send non-primitive values, I will only go and send primitive values. Okay? And then around that time, I needed to create a distributed system where I needed to send whole symbol tables across the network. So my first RA, a guy called Eric Vaslik, very smart guy, he implemented in sort of 89 is when we published the paper, implemented the whole idea of serialization and of objects, of data structures. But there was no remote references there. And then came Java in the mid-90s, and they had this idea of remote references too, which is a really neat idea, I thought. Okay. So there might have been other systems in between, like there was a system called callback that I never looked at, that might have had similar concepts, and Java might have taken these concepts from there. But even though I said earlier Java is maybe not as serious about remote computation as it should be, it's pretty serious compared to its competitors. Okay, so this is what I'm saying here. Java is probably the first system to support remote parameter passing by copy or reference. Okay, previous systems basically focused on primitive values and they sent copies. So it has this good, nice serialization layer, and B, it has this remote object layer also. Okay. So just to make this even more concrete, I'll talk about how things are actually implemented. So serialization is done, and serialization and deserialization are done by object output stream and object input stream. Okay, which are two objects you probably have used. If you read from a socket or write to a socket, you're using these streams. Okay, so that you can go and this is where you can use serialized any object, not just parameters. They have a method called replace object that does nothing. Okay. For RPC, they create a subclass of object output stream called RMI marshaler. RMI marshaler does the same things that object output stream does, except it overrides the replace object method. If that object happens to be an exported remote object, it goes and replaces the object to be serialized by its proxy. Okay, so this makes even more concrete what's happening with Java and how marshaling is different from serialization. That marshaling has this extra step of sending proxies. Okay, So object output stream calls replace object object to determine what object is actually serialized and sent. So RMI marshaller returns proxy if object is a remote and has been exported at compiler runtime. Okay, we haven't seen how you can export things at compile time. That's the old way. We are doing the new way through export object. Okay, and object input stream uses proxy or serial. Okay, so I've shown you a lot of diagrams that took a lot of work to make to explain what explain the concepts. And pictures are worth 1,000 words, people keep saying. But when it comes to studying for an exam or really understanding concepts, I think text is worth 1,000 pictures. Okay, but this is late in the evening, and it's always boring to read text. So I'm going to I put this text in for you guys. When you look at the PDFs, you can read the text, and it pretty much has what I've been talking about. Okay. So that's the basic concepts. Okay, this is enough for you to do your assignment and understand pretty much what's going on underneath.